A Markov chain is a stochastic process, same as before, if it satisfies the Markov property, but the index set is now countable. So the index set can be enumerated, and so we can assume, without loss of generality, that the index set is just 0, 1, 2, 3, and so on. We will also simplify notation here, so xn, so x at index point n, will be written as xn, and the distribution of x0 will be called the initial distribution. The way to generate such a Markov chain is very similar to algorithm 2, except now we don't have the necessity of having a Gaussian distribution. So what we do is we first draw from the initial distribution, and then in each of the following steps we draw xn plus 1 from the conditional distribution xn plus 1 given xn because of the Markov property. An important instance of this is the case where the random variables xn, n larger or equal than 1, are valued on a discrete state space. So a discrete state space means that E, the set of all possible outcomes, is either finite or countable. And then next to this discrete state space, we will demand that the sequence of random variables will be time homogeneous. So the distribution, the conditional distribution of xn plus m given xn, will be the same as the conditional distribution of xm given x0. As such, the probability of any given state transition is independent of time. So it will not depend at what moment we are, it will just depend at what happened m steps before this. So between two states with a difference, with a period of m, the distribution, the conditional distribution, will always be the same. The distribution will then completely be specified by the initial distribution and the transition matrix P, which will define how we go from one state to the next. The transition matrix is thus just the matrix of one-step transition probabilities. So what is the probability that xn plus 1 is xj, given that my previous xn was xi? This transition matrix will thus characterize the conditional distribution, the conditional distribution of xn plus 1 given xn equal to xi. This conditional distribution will be a discrete distribution because of the discrete state space, and it is given by the ith row of my transition matrix P. Therefore, step 2 in algorithm 3 will become very easy, and we can use the methods that we have seen in the third chapter on random variable generation.